A very good day to Doctor. Um, I'm from Group 2. My name is Ishwaji Singh, matrix card number CE200095, and today we'll be explaining about the electropneumatic and integration with relay. So basically what we are going to do is recreate these circuits in the PLC editor, PLC open editor, and run it to simulate it to see whether it functions or not, right? So there are 12 circuits over here, and I'll be explaining from circuit 1 to 4 for now. So let's start. Okay, so first of all, we have been given this circuit over here. Okay, so to recreate this circuit over here, what we need to do is first of all we need to create the file and save it. Okay, and after saving it in the folder of entity1, what we need to do is create the variable over here. Okay, we can edit or delete it. So when we edit it, editing it, we can add the three variables, which is push button 1, push button 2, and the lamp, based on the circuit given over here. Okay, so the type should be boolean type. Alright, and here we can put the documentation as push button 1, push button 2, LED lamp, based on what is needed for our program. Okay, so I already recreate this circuit over here by adding the power rail. Okay, power rail L, left power rail, and this one over here is the right power rail. Okay, and then this one push button 1 and push button 2 are contacts. To add it, we need to use it from here, contact, and we're getting the normal. Normal is always open, and negative is actually always closed. So here we're using the always open, so push button 1 is the normal one, and push button 2 is also the normal one, and this output over here is the lamp. So for the output, we'll be using the normal as well. Okay, there's also negative set, reset, but for now we will just use the normal. And after recreating this circuit, what we need to do is simulate it by pressing this running guy over here, start PLC simulation. Then we have to wait for it to generate it. Okay, now that it's already generated, we will say PLC started. After that, what we need to do is debug instantly. Okay, pressing it, we will be getting this function over here. So now what we need to do is, since this is always open, we need to pass through. Okay, so now the current has already passed through the push button 1 going to push button 2. Since right now it isn't in contact, what we need to do is force through it, and as you can see, the circuit has become green, which means that the current can pass through, and the lamp is already on over here. Okay, so this circuit is fully functioning based on the activity access to it. So next I'll be explaining about the activity number 2. To load it, what we need to do is open, go to the place that you have already saved file, select folder, and it will appear like this. Click on the activity 2, and the same process will repeat. Okay, first of all, what you need to do is add the variables push button 1, push button 2, and the lamp, but based on the circuit given, this push button 1 is the close type. Okay, always close, so therefore the variables are given boolean type, and put the documentation over here. For this always close, what we need to do is put in the contact, and we can choose it to be always close or be negative. Alright, so putting it, just choose the variable PV1 or PV2, and then press the OK to get this one. And then push button 2 is always open, and you'll be getting the lamp when you simulate it and when you debug it. Okay, so for the activity number 3. Press the activity 3, and over here this is always open, always close. And after adding the variables, if this one is false true and this one is false, the current will pass through. Alright, so it's actually the opposite of activity 2. Activity 2, if this was for false, this is false true, the siren will go on. Alright, so these two are actually opposite. And now we explain about the activity number 4. Okay, as you can see here, the circuit given is always close push button 1 and always close push button 2. So what we need to do is add the variable first, push button 1, push button 2, and the LED lamp, set it to the boolean type, and then we run it, simulate it. Before we debugging it, instant debug, right? So from here what we can see is that the circle will become green, alright, and this push button will be need to false, and this one also need to be false for the lamp to turn on. Right, so when everything becomes green, it means that the circuit is fully functionable. That's all from me. Now I will pass to my teammate. Thank you.
So today I would like to explain about the activity 5. So we run. Okay, first, when we run, the timer will just go through the timer and wait until 5 seconds, the lamp will turn on. So if we turn on the PB1, so the timer here will be turned off. So total the lamp will be turned off also. So for timer we also set up to 5 seconds. That's all for activity 5. And then this one is about activity 6. So we also run it. So we turn on the PP1, and until here R1 read also 5 seconds, and it will go to the timer and not the L1. So when go to the timer, it will like blinking for a while. Just now got blinking. Got blinking. So because it go through the timer first, so the lamp will not be turned on. So it go through the timer and go back to the timer here and loop again. So will not go through the lemma. And that's all for activity 6. So now I'm going to explain about activity 7. So for activity 7, so run, debug. Okay. We turn on PB1 and go through until here, timer, and read until 5 seconds, the lamp will turn on. So if we turn off the PB1, it's still operation because the relay here is still going current to make the lamp on. So if we need to stop it, so we just force it here. So sorry, it's turned on the PP2, so the lamp will turn off. That's all for activity 7. So for activity 8, we run. So we need to turn on the PB1. So for now, when we turn on one times, the CV will show 1. And to let the counter operation, we have set to 2 times. So we need to turn off and turn on one more time, so the counter will operation. So go until the timer, and after 5 seconds, the lamp will light up because we set up for 5 seconds. If we need to turn off the lamp, so we just turn on the PB2. So the lamp will turn off. To reset the amount of counter here too, so we just turn on the reset. So therefore for my present. Thank you.
Hai, Assalamualaikum. My name is Farhanis Nabila binti Syariful Bahri. Okay, I will show you the simulation for activity 05.9. Okay. 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 For these activities, this is a simple one. We have start push button, stop push button, relay 1, and lamp. So now we can run it. Okay. Okay, so now you can see when we press the button, that push button, light will on, lamp will on, and when we stop it, light off. Okay, next we move to 10 5.10. Okay. Okay, this is looks. Okay, so we run it. Okay, from this circuit, when we actually when we push the PB1, okay, lamp 1 will light on, and the PB2 is for lamp 2. So sorry, this so has a problem with this PLC. Okay, next I will show you the number 11. Okay. Okay, for this circuit, we use counter and timer. For timer, we use 5 seconds. Okay, counter we use 3 times. Okay, so let's rerun it. Okay, so we try it. Sorry, maybe we can change to another file. Okay. Sorry. When we press the push button start, okay, lights will on, okay, and then for CTU can count until 3 and lamp to on, and this is for 5 seconds. Okay, next we move to 5.12. Okay, same like example 5.11. Okay, we use CPU and timer. Okay, this is same goes when we press the button start button, lamp 1 is on, and when we restart, okay, CPU just for only one time, and for timer use for 2 seconds. Okay, and lamp 2 will like on. Okay, so sorry for this. That's all. Thank you.